So in this video we are going to derive the amount of electromagnetic energy stored in an inductor. Say I have an inductor coil in which a current of I is flowing, and let the inductance of the coil be L. Now by some means I try to increase the amount of current. Say I increase from I to I plus di, and I do it in time dt somehow. So how can I do it? I essentially have to apply a energy source, a volt, maybe some some power source, so that the current increases. Okay, so the current is increased by an amount of di in times dt, and if I want to do that, due to its inductance, an inductive voltage will be generated which will try to oppose the increase of current due to Lenz's law. Therefore I have to do some work to increase the current, to pass this extra current against this opposing voltage. So what will say that opposing voltage is equal to V. So what that will be? That is equal to L, inductance of the coil, times the rate of change of current, which is di dt. So this is the opposing voltage. Now if I multiply this opposing voltage with the current at which is I at that point of time, so this is the amount of power I require to drive the current against this voltage, against this opposing voltage. And since I increase the current in dt time, so this voltage is valid, is in existence for dt time, and within this time the total amount of work that I do, the total amount of energy I require is, this is the power times time is the energy. So Vi dt is the amount of energy required to increase the current from I to I plus di. Now suppose the current is increased from 0 to a value of I. So what will be the total amount of energy required? That we are going to compute. Okay, before that, so here let me put V is equal to L, then di dt times I dt, or let me write it Li di dt times dt. Now yeah, so what will be the total amount of energy when the current is increased from 0 to some value I? So this will be equal to integration of this quantity, and okay, so, and this is then equal to Li di. So let me then put here Li di from an integration over 0 to some value I, and then this is equal to L outside the integration, and then I di, the integration will be I squared by 2 from 0 to I. So this is equal to half L I square. Okay, So that's the amount of work I need to do to increase the current from 0 to I. So that will be the energy stored in electromagnetic form in this inductor.